The first video of my flip video series for this week is on continuity. Now let's try to see what continuity means in the first place. Now, last week I told you visually what continuity really meant. So if you have a graph which is just continuous with no breakages, and then we call that function is continuous at all these points where there is no breakage. So let's kind of see what that means. So now let's take a look at this graph right here. Now, if you take a look at this graph, you will see that this graph does have some breaks. Now, from 0 to 1, there is no breakage, but from 1, there is a break. So it looks as if it is not continuous at this point. Now, once again, if you look at this one, there is a break because the actual value of the graph at 2 is not here but up there. So there is a break here, so it's not continuous at that point. All the way from here to here it is continuous. So from 2 to 3 the graph is continuous, and as you go from 3 to 4 the graph is continuous but not at this point. So you can see 3 points, 1, 2 and 4, where we see breakage because here once again the value of the graph is here, not here where it should be. But now let's try to see whether we can try to put a mathematical, because this is a visual definition. At 1 there is a breakage, at 2 right the graph breaks, and also at 4 the graph breaks. Now let's take a moment to see why. Look at this point right here, 1. Now let's look at the left limit at 1. So if you look at the left limit at 1, so you start from here and you move towards slowly towards 1, you look up, right, and you see the function. Where is the function going towards? The function is going towards 0 as you approach 1 from the left. So the left limit is 0. So what about the right limit at 1? So when you approach 1 from the right, look up and you can see that the graph is at 1 and it will go to 1. So the right limit at 1 is 1, while the left limit at 1 is 0. So the right limit and the left limit are not equal. You can see the break there, right? Okay. So there is no limit. So for this point 1, why it is not continuous actually can be attributed to the fact that there is no limit. So remember the first thing, if there is no limit at a certain point, then there is no continuity. But sometimes you can have a limit but still not be continuous. Let's take this point 2 for example. There is a limit at this point 2. Why? Because the left limit is 1 and the right limit at 2 is what? So you are here, you come down, right? If you go from here to here, you can see the graph comes down from here to here. So the right limit at 2 is also 1. So the left limit is 1, right limit is 1. So there is a limit at 2 which is equal to 1. But still it is not continuous. Why is that? Because now let's take the value of the function at 2. The actual value f of 2, if you call this f, then f of 2 is not 1. F of 2 is actually 2, which is up there because you can see the hole here. So the limit is 1. So we can just say, so the limit at x tends to 2 is 1, but f of 2 is actually 2. So the limit is not equal, so you can see that the limit is 1. So I'm sorry it got cut off a little bit, but that's fine. So you can see that at the point 2, x equals 2, the limit is there. The limit is 1. But if you look at the value at 2, what do you mean by the value at 2? The actual value of the function at 2. The value of the function at 2 is 2, which is different from the limit, which is 1. Limit is 1, value is 2. So you have limit is 1, value is 2. So limit is not equal to the value. So if the limit is not equal to the value, that means there is a jump. That's what accounts to this jump. So that's another way that we get non-continuity. So here this was not continuous because there was no limit. Okay, but here it's different. We actually had a limit which is 1, but still it is not continuous because the value of the function at 2 is not here where the limit should be, but instead it is up there somewhere else. Now let's go to the point here, 3. Now you can see at 3 there is a definite limit. What's the limit? The left limit is 2, the right limit is 2. So at 3 the limit is 2, right? As what is the value at 3? The value at 3 is also 2. So the limit is 2. At the same time, the value at 3 is also 2. So you can see the continuity. So the limit and the value are the same, right? Then you get 3. So at 3 we can say at 3, right, we can say the limit is equal to 2 and the value at 3 is also equal to 2. So when the limit and the value are the same, then we get continuity. So we have 3 situations. So in the first place we had no limit. When we don't have a limit, certainly not continuous. In the second situation at 2 we actually had a limit which is equal to 1, right? But the actual value of the function was somewhere else. That accounted for the jump. And then 2, it is not continuous. But at 3 the limit is 2 and the value at 3 is also 2. The limit is 2, value is 2. Okay, so then at 3 the limit is equal to the value, and that's what ensured continuity. You can further check this further up at 4. Now let's go to 4. Now let's look at the limit. For the limit we only approach. Okay, so left limit would be what? 1. Right limit is also 1. So the limit is 1. What about the value at 4? Well, the value at 4 is not 1. The value at 4 is somewhere here, which is like 1/2. Right? So at 4 the limit is somewhere else, the value is somewhere else. So it is not continuous at 4. Alright, so that's a mathematical way of looking at it. But visually you can see wherever there is a jump, it is not continuous. So there is a jump at 1, so it's not continuous at 1. There is a jump at 2, so it is not continuous at 2. There is no jump at 3, so it is continuous at 3, and then everywhere in between there are no jumps. So it's continuous between 1 and 2, continuous between 2 and 3, continuous between 3 and 4, but certainly at 4 the limit is 1 and there is a jump, right, and therefore it is not continuous. So this is not continuous at 1, 2 and 3, but is continuous everywhere else. Alright, so So here is it's a slightly related concept. Sometimes when you can have only continuity from right. So you can see in this graph, from the right it is continuous, but there is nothing on the left. So we say it's just continuous from the right. So now in this one, it is continuous both from, there is no breakage both from the left and the right. Now if you go to this corner, you can only approach it from the right. So we say that it is continuous from the, sorry, from the left. So you only approach it from the left. So it's continuous from the left. So this is, see, left continuity, this is full continuity, this is right continuity. The main thing is there are no breakage, no breaks either way. Alright, so the definition of continuity is exactly what I told you. The limit of the function must exist and must be equal to the value of the function. Let's go up here. So for here example, the limit at 3 is 2. Left limit is 2, right limit is 2. What is the value at 3? The value at 3 is also 2. Limit is 2, value is 2. So the limit equals to value, then it is continuous. So you know, for example here, this is a very smooth curve, it is continuous everywhere. No matter what you take, the value and the limit are always the same. Now you take this one, right? Now the limit, there is no limit, right? Why? Because the left limit is 0, the right limit is 1, there is no limit, so it is not continuous at 0. But you can still talk about right continuity. It is right continuous as 0 because the right limit is 1 and the value is also 1. Right limit is 1, value is also 1, because you can see the shaded area here. Okay. But the left limit is 0, but the value at 0 is not 0. So it is not left continuous. Can you see that? It is right continuous. Why? The limit at 0 is the right limit at 0. The right limit at 0 is 1 and the value at 0 is also 1. So right limit equals value. So it is right continuous, but the left limit is 0, but the value at 0 is not 0. Why? Because there is a hole here. The value at 0 is 1. So it is not left continuous. Not left continuous, but it is right continuous. But if you just ask, is it continuous? No, because in the first place there is no limit. For the continuity, three things must happen. The limit must exist, the limit must exist, the value must exist, and the limit must be equal to the value. Alright, so let's take, let's go a little further and take some graphs. So is this continuous? Yes, it is continuous. Visually it's very clear. It is a straight line, no breakage, so it is continuous. Right? But now if you look at this one, it is pretty much the same as the previous one, except that there's a problem at 0. You can see that, right? Why? Because the limit at 0 is what? The left limit at 0 is 1. The right limit at 0 is 1. So the limit at 0 is 1. But what about the value at 0? Well, there is a hole there, but is there a value at 0 at all? Nope. So there is no value. So f of 0 is not defined. So the value at 0 is not defined even though there is a limit. So it is not continuous. Remember, the limit must be there, the value must be there, and they must be the same in order to be continuous. If you come here, the limit is still there. See, left limit is 1, right limit is 1. But the value is 2. The value is there, but it is different to the limit. The limit is 1, the value is 2. So it's still not good. Alright. So in this one, if you look at it, there is no limit either, because the left limit here is, I'm talking about the point 0. Left limit at 0 is 0. The right limit at 0 is 1. So there is no limit. So if there is no limit, we can't even talk about continuity. But can we talk about right continuity? Oh yeah, the right limit is equal to the value. So it's right continuous, but is it left continuous? No, it is not left continuous. Alright, we'll stop right here and we'll continue in class.